Hello students, hope you all are doing well at your home. Today we will discuss a topic of monostable multivibrator using 555 timers. I have already sent you the pin description of 555 timer. So today we will discuss how this 555 timer can be used as a monostable multivibrator by applying some external components. So your 555 timer has two comparators, one flip-flop, SR flip-flop. Here we apply externally, we attached a capacitor and a resistor. So how this circuit will work as a monostable multivibrator. Now your monostable multivibrator, this is monostable. So it has one stable state and one unstable state, that is also called quasi-stable state. So let us start. First, this is your ground, 2 is your trigger, 3 is your output. Now, if we assume that Q output of your SR flip-flop is low, when Q is low, or if we assume this is high, if Q is high, this Q is directly connected to your transistor. It will make this transistor to work in saturation region. Okay, this is your output. When Q is high, Q bar will be low and your output will be low. Now when your QD is at saturation, what it will do, it will make the voltage across your capacitor equals to 0, because this is connected to directly connected to ground. Now this will be 0. Now that stage, when your output is low, when your Q bar is low and your Q is high, at that time your output will be in saturation state. That means your output will be at minus V sat. Now this is the stable state of your monostable multivibrator in this case. Now when it will be unstable, when a trigger is applied, external trigger is applied, that will make your transistor move from minus sat to plus V sat. Now this plus V sat, this is your unstable state, or you can say that this is your quasi-stable state, and minus V sat will be your stable state. Now this is high, this is low. Now what we do, we apply an external trigger that will make your stable state into unstable state, or it will switch your circuit from minus V sat to plus V sat. Now how it will happen, if we apply an external trigger at your pin number 2. If external trigger is applied at pin number 2, if we apply a negative trigger, suppose a negative trigger is applied at point 2, what will happen? This is comparator 2. This external trigger is applied at the inverting terminal, and your positive terminal, it will be at 1/3 VCC. When the external trigger is less than 1/3 VCC, this output will be high. As soon as this voltage, it will become less than 1/3 VCC, what will happen? This output will, what it will do, it will make your flip-flop into reset condition. Reset condition means your Q will go low and Q bar will be high as soon as we apply external trigger. Now next what will happen? Your QD, your transistor will be off. When this will be off, what will happen? Your capacitor will start charging by VCC through this path. Now capacitor C starts charging. It starts charging, and this point is connected to the positive terminal of your comparator 1, and negative terminal is at 2/3 VCC. Now as soon as your capacitor starts charging, when it reaches slightly above 2/3 VCC, what will happen? It will make comparator 1 to trigger, and your S will goes high. When this S goes high, your Q will goes high, and it will make your transistor QD into saturation. In that case, your capacitor will again starts discharging because it is directly connected to your ground. Now this is the working of your, this is the